Spring Hill, Tennessee, a serene location about 20 miles south of Nashville and home to a car company with a unique approach to producing automobiles. Saturn, a new car company with innovation in designs, people, equipment, and methods. The Spring Hill facility houses all major manufacturing areas on one site. It includes powertrain with 1.1 million square feet, body systems, and vehicle systems. Within powertrain, one of the major technical innovations is showcased, the advanced application of the loss foam casting process for the production of blocks, heads, crankshafts, and differential cases. The process begins with polymer beads being pre-expanded by steam to a lower density for molding. This special batch-type pre-expander uses a measured weight of beads and expands it to a set volume to assure exact density. After a short stabilization period, the beads are injected into machined and polished aluminum tooling and steamed again to fuse them into a very accurate foam in the shape of a part of the finished casting. The special foam presses have horizontal parting lines to provide positive alignment for more accurate parts, and vacuum cooling to more quickly stabilize the foam. This has contributed to a just-in-time foam operation. The automatic extraction systems also provide for less part distortion. All of the bead preparation and foam making equipment at Saturn was provided by Vulcan Engineering Company's partner, Styrologic. Multiple foam pieces are glued together with hot melt glue to form the more complex final part, complete with internal passages such as oil lines. After a gating system is attached, the foam cluster is coated with a special water-based refractory coating. The coating is dried using low-humidity warm air. The coated dried cluster is then inserted into a special steel flask where dry, unbonded sand is rained around it. The sand must be made to flow into and around the foam without distorting it. The sand filling, together with varying amounts of vibration, must be used simultaneously to fluidize and to compact the sand into all of the internal passages. Control and repeatability are critical in this phase. A pouring basin is automatically placed over the downsprue. Molten metal is then poured directly into the foam, burning it out and replacing it inside the refractory coating. After cooling, the casting cluster is extracted from the unbonded sand, and the sand remaining inside is simply poured out. The aluminum blocks and heads are then water quenched for both metallurgical reasons and to remove most of the coating. The downsprue is removed and the casting is sent on for degating. The loss foam casting process differs from other foundry processes in that there are no cores, no parting line, dry unbonded sand, and no mold wall movement. By simultaneously engineering the engine, castings, casting process and equipment, machining, and assembly, Saturn has been able to realize all of the numerous advantages of the loss foam process. The Saturn block shows a variety of loss foam innovations. Saturn heads are a design engineering marvel also. Between blocks and heads, elimination of 16 feet of gun drilling of passages, now as cast, provided for the avoidance of $15 million in equipment purchases, and decreased the building size by 3 bays. Crankshafts are automatically 100% checked for straightness as cast. There is no straightening equipment at Saturn. Again, the design capability of lost foam allowed for reduced machining stock and significant final mass reductions. Differential cases are produced with as-cast speedometer teeth and dramatic reductions in finishing costs over the normal requirements for this type of casting. No parting line or core prints provided this savings. In addition to these product-related advantages and the avoidance of both capital costs and operating costs, there is a major advantage to lost foam in the environmental area. Externally, air quality and solid waste disposal are greatly improved to the extent that Saturn agreed to and has achieved a zero discharge commitment. Internally, the process is far safer and cleaner than any other foundry process. Not only does this result in excellent conditions for the people working at Saturn, but it has allowed an equipment and process arrangement unheard of before. The powertrain building is completely open between process areas. The lost foam foundries and casting finishing share the room with all machining and assembly of the complete powertrain. There are really 2 lost foam foundries at Saturn, one for aluminum and one for ductile iron. In the aluminum, there are 2 systems, one for heads using a 2-on cluster and operating at 40 moles per hour, and one for blocks, which uses a 1-on cluster and operates at 80 moles per hour. A single system for ductile iron is used for both differential cases in a 10-on cluster and crankshafts in a 4-on cluster. This system operates at 40 moles per hour. All 3 systems are based on the Vulcan Engineering patented True Foam design, which uses link gondolas riding on railroad rail to move the flasks. The entire system is driven by a pair of hydraulic indexers for simple, accurate positioning. This design was chosen by Saturn because it best fit the simple, rugged, and reliable criteria.